Alright, today we're doing special right triangles. 45, 45, 90 type of triangles. You'll notice that every triangle we're talking about is going to have either a 45, 45, maybe 145 in a corner, these two little tick marks possibly, or those arc marks to tell us that the two angles are the same. We have to identify those. It's important we know which kind of triangles we're dealing with, because the next type are 30, 60, 90. That's in another video and another day. So currently we have this example, and we'll have this on every single slide just to help us out. It gives us our formula here, which I kind of abbreviated over here on the left side so we can do our work. And it helps tell us that we have leg here, a leg here, which are the same, right? Two legs have these tick marks telling us they're the same amount, and then the hypotenuse way over here. That hypotenuse is super important. You have to identify the hypotenuse correctly. And you can do so by finding this little box here and going across to that side over there. It's always going to be our hypotenuse no matter which way our triangles are turned. So getting to our first example here, example 1, it looks like we have 7. We've given you this 7. You start here. We start with a 7. We identify it as a leg, correct? Not the hypotenuse, it's a leg. So then we take our 7 and we're going to put it where the word leg is in our formula over here, and then we'll just solve our formula after we write it out. So let's write it out. We would have hypotenuse equals 7 times radical 2, and if you remember, we don't actually multiply 7 times radical 2 because we do not want decimals. We just simply push these together, so we would have hypotenuse equals 7 radical 2. That's our hypotenuse. So we have 7 radical 2, and the best part about this is, remember, our legs are the same, so if one leg is 7, the other leg is 7. Nothing to it, it's a snap. Alright, in example number 2, we have the same thing here, the same setup. Nice little helpful diagram over here. Here's our example 2. You notice it's turned, but remember, it doesn't hurt us. We quickly identify across from this box as this is our hypotenuse, and we need that. This is a hypotenuse. These two lovely guys over here are our legs. And remember, whatever one leg is, the other leg is. So if one leg is 3 radical 2, the other leg, 3 radical 2. Nothing to do. It's the same thing. Now, we do have to find the hypotenuse. There is some work to find the hypotenuse. And remember, we were given the leg. I know that by following this diagram over here. The two legs have the tick marks on them. The hypotenuse is the guy across from the box. So I'm going to do the same thing as the last slide. I'm going to write my formula over here. Equals 3 radical 2 times radical 2. All I did is I took my 3 radical 2 from my leg, and I put it right where the word leg is. And then I wrote times radical 2. Well, if you remember from class, radical 2 times radical 2 is nothing more than 2. The radicals actually cancel each other. So I would have 3 times 2. Our hypotenuse is 6. 6. Okay, example number 3, and clearly our most challenging example yet. This one we all need to pay attention to. We have our diagram over here helping us identify everything. Our picture is turned once again, but we have the 45 here telling us that it is a 45, 45, 90 triangle. You then identify the 10 as the hypotenuse. Remember, across from the 90-degree box here, this side, always the hypotenuse. These two guys are the legs. So no more of this, we gave you a leg, the other leg's the same thing business. We gave you the hypotenuse. We have to then take that 10 and put it over here where the HYP is in our little formula, and then simply solve our formula. So I'm going to take my 10 and write 10 equals, right, leg, I'll just abbreviate there with a little L, times radical 2. Okay, well, in order to get rid of our radical 2 there, it's being multiplied by the L. We have to divide, so divide by radical 2. Sorry about that. That'll get us to cancel. We have to do the same thing over here, radical 2. So we have 10 radical 2 equals L. Yep, and here's the challenging part, right? We cannot have the radical 2 on the bottom. You can't have that square root symbol in the denominator's place. So you must then solve further. Remember, it's called rationalizing the denominator. Take our radical 2 there. I'm just going to rewrite it. And we have to multiply whatever's on the bottom like that. And if you remember from before, we just push the 10 and the radical 2 together, no multiplying those. We have radical 2 times radical 2 on the bottom, and from example number 2, we remember that is just 2. Right? The radicals cancel each other out there. And we can then simplify just one tiny bit more. This 10 and this 2 are on the outside. They are not underneath this little radical symbol, so we can reduce those. They have nothing to do with this one over here. This guy stays alone by himself. So we're actually going to reduce this one more time and find out that our leg equals 5 radical 2, right? 2 goes into 2 one time, 2 goes into 10 5 times, so we have 5 radical 2. You could write this over 1 if you choose. We don't need to do that. This is our leg. One of our legs is 5 radical 2. And if one of our legs is 5 radical 2, let me erase that a tiny bit. Then our other leg is 5 radical 2. Remember, the legs are the same.